Today we're going to start talking about strings. But before we do, I want to say something about characters. And you have seen this in a Zybooks exercise that there is a primitive called char. Char is a character. And we think of this as the value of this as being an alphabetic character, and you'll note that there's a single quote on each side. So when we write this code, this happens. It sets up a place in memory called ch, big enough to hold a character, and that's actually 8 bits. 8 bits is a byte. You need a byte to hold a character. And the character that we're putting in there is this lowercase k. Again, single quotes, and it makes a big difference whether it's single or double single quotes. This is a string, and string is something that we would normally in English call a word. It consists of one or more characters. We put the double quotes on each side, and when we do that, then the effect is to do this. It sets up a place in memory called W, and it puts this string Monday in there. I said char is called a primitive. A primitive is something that just has a value, nothing else. Int only has a value. The value is a whole number, an integer. Double only has a value. String is not a primitive. String is an object, and objects not only have value. In this case, its value is this string, monday, but objects also have methods that can act on them. So we can do more with an object than we can with a primitive. With a primitive, all we can do is set its value or get its value. With a string, with an object, we can do a lot more. In everyday language, we tend to mix these things up, characters and strings. So, for example, we just put a K on a piece of paper, or we type it at a keyboard, and we don't worry about, is this a character or is this a string that consists just of one thing, one letter. But the machine cares. It stores these things differently. It will store a single character in a byte. Even if the string only consists of a single character, for example, here we can have a string, let's call it my S, and it can have just a single character, in this case a lowercase k, but because it's a string, I put double quotes on each side, and it is stored differently. This string consisting of lowercase k and this character consisting of lowercase k are two completely different things. If I print it in my output line, it will look the same. It's a lowercase k. But just because that's how it looks when I print it, that doesn't mean that's how it looks, sort of thing, inside the computer. It is stored differently. They are both stored differently in the computer. And so we have to start thinking about things more precisely. A lowercase k can be a character or it can be a string, and depending on what it is, I treat it differently. So the first question I expect you to ask is, can I change a character into a string? And the answer is no. You cannot change one into the other, nor can you change a string into a character. But you can make a different thing so that looks the same. So here we have a character called K. How would I change this into a string? I'm going to call this string your string, or your S, and I want it to be this, just a lowercase k. Well, I take a string, an empty string, and I concatenate my character onto it. So now I've got an empty string concatenated with a character. So we get some implicit casting going on here now. I've got a string and I've got a character. That character is converted internally into a string and then concatenated with the empty string, and therefore it becomes a string. And that string has a K in it. So right over here, you would get your string, which has the K in it. But I had to concatenate it. I had to take my character and concatenate it with an empty string in order to get a new string. If I have a string consisting of just one object, one letter, one character here, how do I get the character out of it? I have to use a method called char@. So I can say char your C equals, now I take my S and I can say char@0, and that should be a lowercase t. And that produces K, a character K. So what did we learn? We learned that characters and strings are different. They are stored differently, even if they only consist of one letter. And incidentally, a character doesn't have to be a letter, an alphabetic letter. Just call it, what shall I call it? My letter, my L equals, and here I have a %sign, and that is a valid character too. So it doesn't have to be alphabetical. It doesn't have to be an alphabetic character. It can be a %sign. It can be anything that you can find on a keyboard. So that is a character. But when we assign it, we have to put single quotes, and it is a single alphabetic or digital. It could be a 9. So on this line we had a character which was a %sign. On this line we had a character which is a 9. Now this 9 is not an int. I cannot do arithmetic on it. It is a character. It's a character in the sense that a telephone number consists of characters. You don't ever think about doing math on a telephone number in the same way you cannot do math on a character. So characters, single characters, strings, one or more, and even none. Here's an empty string. So you can have a string that has nothing in there. You can have a string that has one thing in there, and you can have a string that has multiple things in there. You can even have a string that has more than one. So string here is another string, and it has spaces in there, and that's fine too when you've got a string. So a string, as long as it starts with the double quote, ends with the double quote, anything in between it is the string. So that is a string, and this is the difference between a string and a character. I said here char at 0, and I'll use this string as an example. In computer science, we always start at 0. So this first character here is in place 0. And then we start counting 0, 1, 2. We count the spaces because a space is a valid character. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is number 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it starts at 0. So supposing I wanted to get that y out of there, what place is that? 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I said char something t equals phrase, because that's its name, dot char at did we say 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. Then I would get the y. So this gives me y, lowercase y. So the name of the string dot char at, and don't forget uppercase A, and then in parentheses the index of the character that you're looking for. So that's how you can get characters out of a string. If you say char at 0, you're going to get the first character. And since my S had only one character in it here, then we got the K out of it, the first character out of it.